Well, hey YouTube, petey twofinger here. I'm going to be building a pair of Spaceman Effects Sputnik 2 germanium fuzz clones. So the Spaceman Effects Sputnik 2 is a germanium fuzz tone pedal that sells for, well, there's one on reverb.com for $1,800 right now, for a good reason. There is a Veroboard clone for, I think somebody's got that going for like $250. But this is a very complicated, like king of all fuzz tone, like ultimate guitar pedal. For many reasons, and I'm going to try to go through that. It's a challenge for me because I'm having to order a bunch of parts that I don't stock. A lot of that stuff is it's unavailable right now. So I'm waiting for the manufacturers to release more on the market and then grab those up when they come online. It's a complicated circuit that seems to really make sense to me from looking at it. And I've checked out the videos on it. I know the reputation of it, and I'm really excited on the opportunity to be able to build a couple of these and keep one for myself. The other one, I'm not sure who's going to end up with that. More than likely, I contact some people in the business, some professional guitar players, and they're probably going to want it. If not, I'm going to end up selling it to someone. Whoever guitar player wants it, it can be yours. So here's a look at the bill of materials. It includes some stuff I'm going to have to order. So I guess there's a goofy. Don't listen to me. There's some very unique components in this circuit. There's some unusual diodes. There's ferrite beads. There's an isolation transformer on the input. There is 5 different types of transistors. I think there's 7 total. There's 3 germanium transistors. There's unusual non-polarized capacitor that are very expensive. And then unusual value of different capacitors. And not to mention the giant black powder coated chassis I'm going to be purchasing. It's got 2 stomp switches, 3 toggles, a 2-way, 2 3-ways, 4 knobs, and then 2 LEDs. There's 2 internal trimmers. I'm going to be socketing one of the diodes to select an optimal one for the performance. And then there is 3 socketed transistors I'm going to be swapping in and out. We'll probably test them and put the ideal ones in. And then there's 2, like instead of a knob, this is something that it's a little tiny adjuster that you adjust once and set it for optimal performance, and then you don't mess with it. It's called a trim pot. So between those 2 trim pots, that socketed diode I'm going to be optimizing, and then the 3 transistors, there's kind of a lot of fine-tuning to get this unit to sing. So between special ordering all these unique components, stuff that's not on the market right now because the manufacturers have to release more, then they'll be bought up, and then paying all of the shipping on all of these unique parts that I'm ordering from multiple suppliers, this is going to add up to be just outrageously expensive compared to my normal usual build when I can order all of the easy to obtain components from one supplier. So this is why you see the high price tag on something like this. A lot went into the design on it. It's much more complicated than a normal pedal, and it performs like that, you know. So it's not like this is fairy dust. This is a real deal thing, and I can explain some of that to you as we go along. But I wanted to, this is just a broad outline of what I've got here. I've got the guy's, his personal notes on the circuit. I found a forum where they dissected it and reverse engineered it, and talked about that and the different part selections. So combining all that information and then trying to make the purchases, it's going to be a complicated, time-consuming process for me. Back to the germanium. In 1954, when they invented the first transistor, we didn't have silicon yet. Okay. Nowadays, most of the times, we reach for something called an operational amplifier, an op-amp, which is an IC chip. So the symbol for that is a triangle. You have an input and another power input for the voltage, and then the output on the other end of the triangle. So you could think your signal comes in, beep, 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 and then the power comes in, the 9 volts, and what comes out is whoa, 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 because it's the power being combined with the audio signal, this triangle of the output. So a transistor, you could think of the same thing. It's got 3 legs on it. One's the power input, one's a signal input, and then you've got the output. So the germanium transistor, that was the first one, and it had this wonderful spongy tone, this unique attack, which colorized the first fuzz tone effects, and you just can't get that sound anymore. This is like Eric Clapton, Jimmy Page, all of the real old school rock and rollers had this tone, this fuzz tone, that you just can't replicate it with today's modern gear. And there's a reason for that, is because it used a germanium transistor. Now, germanium has several issues. One being leakage. It leaks some of the signal. The actual part is not efficient. And you have to go through multiple units to find one that leaks just the right amount. You want a little bit of leakage is good, not a lot. That's a problem. So when you want to use a germanium transistor, you can't just buy one. You have to buy 20, and maybe you'll get one good one out of that 20. Because not only is there the leakage, there's the HFE, and that's just like the gain. It's just like the volume. How much does this little guy actually amplify? Because when you buy them, they're rated, it'll be anywhere from 50 to 200. And let's say you need them to be right in there at 70 for this circuit, which is the case. So you need 3 germanium transistors with HFE of 70 with low leakage. So in order to hunt those down, good luck. And they're not cheap. And then you got shipping and the extensive testing process. Now, I made a video on testing. This isn't something where I'm just like putting a socket in there instead of soldering it and putting a socket in and then just listening and go, oh, that one sounds a little better. I do that, but I also measure them. So I built the germanium test rig, and I have a video. If you go back a few years, I have that video. But also my brother recently, he obtained this out of someone who passed away out of their estate. And this is a Heathkit transistor testing rig. And right in the first pages, they have allotment for germanium and for leakage and HFE. That's what it does. And I got some D batteries in there. So yeah, it's going to be another video where I show this thing in action, how I'm testing the transistors. I may also have my little digital rig that I built when I went through my germanium phase years ago, because I did. I really like the Baldwin Burns Buzz Around Mic Tester edition, which uses a single germanium in the third power stage, the distortion stage. The first preamp stage, or the input stage, it doesn't have any effect on the tone. He replaced that germanium transistor with an op amp, which is genius, because then you only use one. It isn't as temperature sensitive, because that's the third point on our why germanium they don't use them anymore. It isn't just because they're old stock and you can't get them, is because there's a temperature sweet spot. If it gets too hot or too cold, sound's going to cut out. So basically, the other angle on this is, when you think about it, back then they didn't have humbucking pickups so much. Most of the guitars had single coils, and that's what these were designed for. So anything but is not going to really work. It'll work, but it's not going to sound good. If you want that real sweet fuzz tone with a germanium box, you have to use a guitar with a single coil pickup. And you can't have anything else in front of it, because the fuzz circuit, it needs to see as part of its circuit the high impedance of a single coil pickup. If you take a guitar like a Strat, use just the single coil pickup, not the two combined, the humbucker setting. You just use a single coil and a single cable going directly into the input of that fuzz box. You can get that tone. But anything else, and see, this is the problem, because everyone has a buffer. Everyone has a tuner first with the buffer to eliminate cable lag, and tones suck. So you just can't do that for germanium. You have to have the capacitance of the cable and the unbelievably high impedance of a single coil pickup. So this is why so many people nowadays will they'll put a fuzz box in the middle of their pedal board, or they've got humbucking pickups, or EMGs, actives. So if you want that sweet, sweet fuzz tone, there's no way around it. You got to plug your guitar straight into it. And that's just not going to happen for most players. There's many reasons why that's not going to happen. So this is where this gets brilliant. The Spaceman, Spaceman affects Sputnik 2, has a decoupling input transformer. Okay, right in here. And basically how a transformer works is it's a big coil with another big coil right next to it. So your input signal comes in, spins around that big coil, and creates what's called a magnetic field. And that springs out all around in the area around the coil, and it gets picked up on the other side of the coil. They're right next to each other, and then comes out. So they're connected. The signal passes through, but they're not connected. They're disconnected. There's no direct connection. So what the fuzz circuit sees is the high impedance of this coil. Because what's a pickup? It's a coil. And what you really got going on is whatever. You could have your EMG active humbucker go into a wah with a booster, with a tuner, whatever you want. This fuzz pedal is going to be fooled into doing its trick and really singing, giving you that pure germanium fuzz tone, because what it's seeing is the high impedance effect, the load that it needs to see, which is just like a single coil pickup, but it's this transformer. Now, the reason that they don't do this all the time is because transformers are really expensive. And right now, like I said, ordering these parts, they don't even have them. They're all sold out. I'm waiting for the people who manufacture this transformer to release more onto the market, and then I'll be able to get it. So this is going to be a little while. June 5th is the date I've got on these transformers coming back on the market. In the meantime, I'm going to be ordering, I've got ferrite beads, I've got the unusual, it's a Zener 15 volt Zener diode that comes out to a 0.500 millivolt voltage drop. There's non-polarized capacitor, which is really expensive. It's a WEMA. That's what they use in crossovers. I got to get non-polarized capacitors. Unusual value. There's some of those in there that I need to order. There's all the germanium transistors. There's other, and I'm going to have to go through those and test them and find 2 sets of 3. And then there's total of 4 other types of transistors I have to get. And then the board mounted 90-degree board mount potentiometers. The trimmers I don't have. I have to get. I'm going to order some really nice input and output jacks, and the stop switches, and then powder coated chassis. So this is going to be a loving, time-consuming project where, I mean, I always do. I test each component that I install, because I received an order from Tata where they were labeled 1K and they were 220K, the resistors. So I'm going to build this. Here's the bomb. I give this to my old lady. She pulls the parts. I install it. You know, I make it, test it, and the thing ain't working. And I'm pulling my hair out for a day. And then I go through and I'm testing each, because I go really slow. I can sling parts in there and just solder flying and burning the top of all the film caps, you know. I've done that and I can do that, but on something like this, I'm really going to take my time. What I found was they had shipped me in error. They had shipped me the wrong resistors and labeled them improperly. So I test each component. But this is going to be a real loving build. And like I said, there's that diode. I went through, he's got notes here, and I went and found a forum where people have reverse engineered this, and they've all tried experiments on different components, and they have recommendations on slight variations you could get to tune this to make it really optimal. So I've got all of that information here, and there is a couple of points where you can substitute things. So I'm going to be putting sockets in, and then trying different things and getting test measurements and getting those voltages to match the numbers that I have here from an original unit. And then on the forum, there's more sets of numbers. So it's going to be a long process. There's 2 trimmers, set and forget potentiometers. It's like a knob, but it's mounted on the board that you attach your meter to certain points on the transistors and tune them to get an appropriate value. And then there's the actual three main transistors themselves. So I have this bag. I have a bag of germanium here that I was gifted from a guy named Pig Shimmy Photon. He was the guy who gave me the PCBs. I've got some GE here, but I really don't think I have enough. I can do something with this, but they won't be. I know I have two that are in the around 70, but I need 3. I'm going to need 6. I'm going to make 2 of these things. So it's going to be a long, loving project, and I'm probably going to make a few more videos on this. So let me know what you think. Again, I'm making 2. I'm going to keep one. Somebody else is going to end up with the other one. Could be you. So yeah, the Spaceman FX Sputnik 2 germanium fuzz. I'm not going to call it that. Ferrite beads, GE D9E diode, 1N965. Couple of DPDTs, BS250, PNP germanium, 2SB172 or MP16A, 80 HFE, BS170, 2N3904, 2SK30AY. Yeah, so there's some, and it's going to be a positive, a negative ground. Excuse me. The Boss pedal is the standard thing where you plug in that 2.1 millimeter jack to your pedal for powering. That's positive ground. This is negative ground, so you can't like take your power supply. You know, all pedal boards have that thing where they have it's a power supply. I'm Voodoo Labs pedal power plus power bank, whatever they call those things. You can't use that because this is reverse polarity. So if you try hooking that up, it'll boom, it'll explode your power supply because you're literally reversing the polarity, and that'll, through the connections of the ground, the common ground, the power supply connecting the circuit, it's like just throwing a literal wrench into the machine. So probably run this off of a battery, and they don't like alkaline batteries. You got to use a dollar store carbon zinc battery. So there's just so many different little tricks to get this to sound really right. And that's going to be applied through the process of making it, is tuning it and testing it and really getting it to the point as close to perfection as I possibly can. So that's what I'm going to be getting into, the Leica germanium fuzz. I built 5-knob fuzz factory, which is GE. It's a fuzz face where he ripped out all the resistors and substitute controls, so you can really adjust it, and that's a wonderful effect, but it's too tweaky. It's too many knobs. I built the Baldwin Burns buzz around, that's probably my favorite germanium fuzz. The op amp, the mic tester op amp version, where the first input stage is an op amp and you only use one germanium transistor. I really love that. It's very versatile. It gets 3 different sounds with just a couple of knobs. That's a 3-knob fuzz. I built all kinds of fuzz face, charge pump fuzz faces, played around with that, Japanese transistors, Russian dual stock transistors, all kinds of germanium circuits I've monkeyed with. And this one looks like it's really going to be the king daddy. Really excited about this. So special thanks to Pig Shimmy Photon, and stay tuned for more on this exciting germanium fuzz project. It should be the king ultimate fuzz pedal that I'll ever build. Alright, you guys.